Hey guys, it's Richard from Monospace. In today's video we're going to create the game Tic Tac Toe with React.js. It's a fun little project in case you're just learning React.js and want to apply and improve your knowledge. So let's get started. In the first step we use create React app to create our React app. It's going to be called Tic Tac Toe and we're adding the template parameter to set it up as a TypeScript project. I personally like it a lot better to develop type-safe code, and React has great support for it. And running this can take a few minutes, so don't worry. Once it's done, we are running the npm start command, or if your IDE supports it, you can just click the execute button next to the start script's name, and then that will start up your application server at localhost 3000. And here we can see our React app up and running. Okay, first we're going to create a components folder where all the components of our application will live. And inside of it, we're going to create our first component called board. So the board component is essentially where all of our gameplay will happen. And inside of this folder, we're going to create a board.tsx file for all the React code of our component. And also a board.scss file. We're going to use SCSS in this project because it's just nicer to be able to nest selectors inside each other. And I will show you in a minute how we can set this up within our React app. First of all, inside of our TSX file, we will create a React memo component. I have set up a snippet for that in my editor, which is always helpful for boilerplate code like this. We don't need props on this component for now, so we can delete this. And then we have our empty board component that will host our tic-tac-toe game. And now to be able to use our SCSS file, we need to open our terminal and install a package called Noughts first. So we're going to type npm I or install Noughts and hit enter. Don't worry if this takes a few seconds on your machine. Okay, and when our installation is finished, we can then just import our SCSS file like this from our board.tsx file. And then our app should still be able to run without problems. For now, in our app component, we still have all the scaffolding code that create React app automatically created for us. So let's get rid of this. We will just leave all of this stuff and we will leave the div and give it a class name of app container. And inside of it, we're going to create our board component instance. And this should be enough to be able to see an empty page for now in the browser. That's because the board is still empty, of course. So let's put some text in there. And then you can see this hello come up on the page and no error messages, which means our SCSS file could be loaded successfully. Okay, the first thing will be that we will render out our 3x3 grid. And to do that, we will remove this for one moment. And in our return statement, we will create one div that's going to be used as basically our board container. So we're giving it the class name board container. The board container will contain some other stuff later, but for now inside of it, we create just one more div for our actual board. And inside this board, we will use an expression that basically loops through a 3-element array representing our 3 rows. And inside of each row, we will loop through another 3-element array, and each element in here will represent a column inside our grid. So now we have this 2-dimensional loop, and inside of here, our row and column indices will represent one particular cell in our board grid. So we can render a div for the cells here, and we will give it a class name of board__cell. And just to be able to see what is actually happening here, we will render out the row and the column inside of each of these cells. And when we look at the result of this in our browser, we can see this is the list of our cell divs, each with their row and column indices. And we see there is a warning in the console because we didn't use the key prop on our cell divs when we looped through our arrays. So we can fix that by just passing a key prop in here with some string concatenation that contains our row and column index, because the combination of the two will be unique for each cell. And that should fix this warning when we refresh our page. But of course, we don't want our board cells to be rendered below each other, but there should be a 3x3 grid of cells. So let's go into our board.scss file. We will use our board class, and inside of our board class we have our board__cells. So with SCSS we can use this syntax using the ampersand operator in order to not have to repeat the parent selector over and over again. First though, let's give our board a display property of grid, and then we say that our board should have grid template columns of repeat 3 times and they're 1 fraction each. And the same thing for the grid template rows, also repeat 3 times and 1 fraction each. And there we have it, our board is now a 3x3 grid. And then for the cells, we give them a border property with a nice color. And to center all the contents of our cells, we will give it display flex, align items center, and justify content center. And that will make it look like this. But we don't want our board to take up the full width of our browser window. So inside of our SCSS file, let's create another selector for our board container element. And then let's move all the other stuff in here, and then we're going to limit the width of that to 300 pixels. And to have it nicely centered, we are going to give it margin auto as well. And this will center it like this. Then for our board itself, we're going to tell it to take up the full width of its container and that its aspect ratio is always 1:1. And as you can see, this will make sure that it's always a square, like people are used to see when they're playing this game. And while we're at it, let's also give the board cells a little gap to each other of maybe 8 pixels. And the entire board can have a little box shadow using the same color as for the border of the cells. And it's also going to get a border radius of 8 pixels. This doesn't look too nice for now because all the background is still white, so let's fix that quickly. First of all, inside our app.css file, let's remove all this generated code and then rename this to app.scss. And also inside our app.tsx, let's import it correctly. And then inside of here, we give our app container a background color of 009393, which is a nice sort of medium teal color. And a height of 100% of the viewport and display flex. And this will center it nicely in the viewport. Then we will make sure that the contents of our cells have a nicer color. We use a bright turquoise color that fits nicely into our color scheme. And also we're going to make the text inside our cells a little bit bigger because there are supposed to be big noughts and crosses inside there. And then last but not least, let's give the entire board a little padding, maybe 16 pixels. And this will give the final touch to the design of our board. Next up, I would like to create a separate component for our cells to split up the responsibilities a bit more. So in our components folder, we're going to create a new folder called cell. And inside of it, we are creating a cell.tsx and a cell.scss file. In the cell.tsx file, I will use my snippet again to create a memo component and call it cell. And for this component, we will also create some type definitions. So let's create a cell.types.tss file in this folder too. And in the types file, we will create an empty interface for our cell props for now, which we will come back to a bit later. And then back in our TSX file, we will import the props interface. Back in our board.tsx, we will grab this line of code that renders our cells and copy it over to our cell.tsx. And we will remove all this stuff for now, so our cells will stay empty for the moment, and we will deal with what to put in here in a minute. Then back in our board component, we need to render the cell component in here where our div previously was. And here we will need our key prop again to be able to render this inside of a loop without warnings in the console. So we will use the same value for the key prop that we had previously. Let's check if this still looks as expected, and yes it does. The cells are now empty, and later on, of course, we want to be able to put noughts and crosses in there by clicking on the cells. Okay, next up we want to create the state needed for our Tic Tac Toe game. So let's close all these SCSS files for now, we won't need them for this. What we're going to do is we're going to create a folder called model, and we're going to put a game.types.tss file in there. And what we will do here is we will create some types that will help us manage the state in our application. So the first piece of state we want to define is which player's turn is it. So let's create a type called player, which is either X or O. So at any point during the game, it is either X's or O's turn to make the next move. Unless, of course, there's already a winner, but we will deal with that a bit later. And then our game state will basically consist of a player that describes whose turn it is. And also the current state of the board, so which moves have already been played by both players. And the 9 cells of the board will be represented by a simple list, where each element can either be a player that has put his piece on this cell, or it can be null, which means this cell is still empty. So starting out, the board state will be a list of null values, and as the game goes on, the players will fill up the board with their X's and O's, or noughts and crosses. Then what we're also going to do is we want to create a util folder. We don't want to put it inside the components folder, but we want to put it inside our source next to the model folder. And inside there we will create a game.utils.ts file. And we're going to create a few variables in here. First of all, we will create an initial game state variable in here, which is an instance of our game state interface that we just created. And this will contain our board state, which, as I said, is an array of 9 elements. And we will fill this array with all null values initially. And we're going to say that the first turn goes to player X, just arbitrarily. So we're going to assume that X is always the player who begins the game. And with this now defined, we make sure that all files are saved, and we're now ready to use some state in our board. We are going to use the useState hook up here. The type of state we want to manage is a game state, and initially it's going to be our initial game state. The hook will give us a game state object and a set game state function. So the game state will contain the actual state, and the set game state function will be the function we can use to manipulate the state of our board. So when we call this function, we can update the state, and the UI of our board component will update accordingly. Okay, so next we want to pass the state of each cell to its cell component. So we're going to define in our cell props a property called state. And of course there's either going to be a player in that cell or it's going to be null, meaning no player has put his piece on this cell yet. And let's not forget to import the type from our game types file. And then in our cell component, we can use this prop by using the destructuring syntax in the parameter to our React memo callback function. And what we're going to do with this state prop is we will use it to determine which cell content to render in the cell. So if the state is defined for our cell, then we're going to use the uppercase version of it, because remember, this is just the letter X or O, depending on which player has clicked the cell. And if there's no state yet for this cell, we will just use an empty string. And then our cell content will be rendered inside of our cell's div element. And of course, we have to pass our state prop to the cell components. But how do we get the specific state of this cell? At the moment, we only have the state for the entire game, where the board configuration is encoded as a flat 9-element array. But inside our 2-dimensional loop here, we have a row and a column index. So we need a way to convert a row-column pair to an index between 0 and 8 to be able to address our flat array. And to do that, we are going to have to create a little helper function inside our game.utils file. We're going to call it coords to cell index, and it's going to take in some coordinates. We're going to define this type later and return a number from 0 to 8. And for the coords, let's go to our game.types file and define this interface. And it's just going to be a row and a column, which are both numbers. And then we can import it here. And basically what our function will do is it will take the row from the coords, multiply it by 3, and then add the column to that. So when you imagine the 3 by 3 grid of cells flattened out into one dimension, this will start to make sense. Then you basically have 3 rows stacked behind each other. So the row index will determine which of these 3 blocks the cell is in. And then the column index determines which of the 3 cells of the block it is. So with this helper function now ready, we can go back to our board and we can pass here our coords to cell index. And we're going to pass the row and the column in there. But of course we don't want to pass our cell index directly, but we want to look up the cell state for this index first. So we need to use our game state and get the board property, which is the array that contains the state of all the cells. And as the index for the array, we're using this call for the coords to cell index function from down here. And to be able to use the row and column indices, let's also move this line down here inside the loop. And then we can use this cell state to pass it to the cell component as the state property. If we save this here, we can see our empty board gets rendered. But to really check if this works, we can just for a moment change this initial state in our utils file, and we will just put some random values into this array. Let's just make sure this is really 9 elements. Okay. And you can see when we refresh the page, our new board is rendered and there's X's and O's and also empty cells in here according to our initial state. Okay, to actually be able to play the game, of course, we need to be able to not just render, so that when you click on a cell, the player whose turn it is should leave his X or O on that cell. So what we need is to detect clicks on our cells, and when a cell was clicked, we want to communicate this back to our board component, so the board component can update the state according to this click. And to do that, first of all, in the props of our cell component, we're going to define a cell clicked function that will get passed into our cell component and called each time the cell is clicked on. It can just be a void function that doesn't need to return anything. And then when the user clicks on our cell, we want to call our cell clicked function in here. Of course, we have to add this prop up here first. And then we can call this function in our onClick down here. And now, back in our board, there is an error down here because we don't pass this function yet. So let's create a function here that handles the clicks on our cells called handleCellClick. And what this function is going to do is it will take in the index of the cell, which is just a number, and it's going to be called from within the cell. But first, let's rearrange this code formatting a bit and not put it all in one line, like this. This makes it a lot easier to see what props we're passing in here. So we're going to pass the cellClicked prop. And when this is called, we want to hand it over to our handleCellClick function. And inside of here, we also want to pass our coords to cell index value because this is what calculates our cell index. Sorry, of course, this has to be a const. And it's not very nice to have this called twice, so we're going to create a const for that to store the cell index here. And then in the other 2 places, we can just replace that call and pass in our cell index. Okay, now in our handleCellClick function, we're getting past the cell index. And what we want to do here is we want to use our setGameState function that manipulates our game state. So remember, in our state, we have the board, which is a 9-element array of cell values, and we're storing in there which player's turn it is. So those are the 2 variables we need to manipulate when we're calling our setGameState function. And how are we going to do that? Well, first of all, we want to create a copy of the board from our current game state to make sure there is a new array reference when we update the state. To do that, we can just create a new const and use the array destructuring syntax on the existing board from the game state like this. And then next up, we are going to have one special case that we need to handle, because of course a player is only allowed to put his X or O into a cell that is not yet taken. So we need to check if there is already something in the board cell determined by our cell index. We can also check it like this to make sure it will be a Boolean. So if there is something other than null in this cell, in other words, if this cell is already taken, let's create a little comment here. And in this case, we can just return, so nothing would happen and no state would get updated. If we pass that check, so if our cell is not taken yet, we can just put into that cell the piece for the player whose turn it currently is. And that information, of course, comes from the turn property of our game state. So whichever player's turn it was, puts his piece on the board at position cell index. So here we've worked on our copy of the board for now. And now to actually update the state with this, we need to call our setGameState function. And we need to pass the new game state in here. So for the board property, this will just be our copy of the board that we've created. And instead of this, we can use the shorthand property for this. And we need to give the turn to the other player. So whoever played his turn just now, the other player will get it next. So basically, if the turn from the old state was O, then it will be X now, or in the other case, it's going to be player O. So this is essentially the logic to manipulate our state, and let's check if this works. Okay, so let's first remove our random initial state here and change it back to our empty board initially. And now you can see that I can click on this cell to put an X in there, then on this cell to put an O in there, then another X, an O, another X, another O, another X. Perfect. We can put our pieces in here. It's alternating between the players. But as you can see, the X's would have won this game twice already, but the game didn't stop me from playing. So we need some kind of win detection, and we're going to look at that in a minute. First though, we want to clean up our board component a little bit. First of all, at the moment we have no idea whose turn it is at any point during the game, so we want to include that information underneath our board. But first let me clean up a bit and let me create a function to render our cell basically. So inside here we are gonna put all this stuff, and then I will just fix the formatting here. And obviously we need to pass in the row and the column for our cell. And then we can just call it here and just pass in the row and the column. So that makes this block down here much more compact. And then we want to create our game info block that holds the information which player's turn it is. So let's also create a function called render game info like this. And then inside here, we need to pull this information from our game state. So we're going to need the turn property from the state. And then we can create a div element with a class name GameInfo. And then in here, we are creating a span element. And for the class name, we're going to call it GameInfo__turn. And in here, we just put its turn to uppercase, because again, people are used to uppercase X's and O's when they're playing this game. It's X's or O's turn. And then underneath our board div, we can just call our render game info function. So let's try this out. Let's reload so we have a clean new board. It's X's turn, then I put my piece on, it's O's turn, then it's X's turn, then it's O's turn, and so on. So it works. It just doesn't look very nice so far, so let's give it a bit of styling. So in our board.scss, below our board class, we're going to create our new selector for the game info class. And first of all, let's give it a bit of margin to the board. Let's put it in the center, and let's also make the font size a little bigger. Also a bold font weight, and we're going to give it a nice color. Let's use this bright turquoise color again here. And this is what it looks like in the browser, and it looks a lot nicer. Okay, now we always know which player's turn it is, and we can put pieces on the board, but we still have no way of detecting when one player has won the game. In this case, even though O has already won the game, we can keep playing until the board is completely filled up. So what we want is to put into our state the information if there is already a winner for the current game. So we go to our game.types file and we add a property for the winner. It can be undefined, so we put a question mark, and then let's see. This could be just a player, so it could just say whether X or O has won the game, but we also want to be able to show the line on the board with which he's won the game. So we don't just want to be storing the player, but we're going to create a new interface for this called winner. And we're going to create it underneath here. And it's going to consist of the player who has won the game and also the winning line that he has won the game with. And this winning line is just going to be the list of cell indices of all the cells in the line. So it's going to be an array of numbers. So now that we created the types for it, let's write some logic for detecting the winner. So back in our game.utils, we want to add a function for this. And it's going to be a little bit tricky, but we're going to go through it step by step, so don't worry. So we're going to call this function detectWinner. It's going to take in our board, which is obviously, as we know, an array of player or null values. So remember, this is what we defined the board as. Let me quickly import the player interface here. And then our detectWinner function will return a winner object or undefined if there is no winner yet. And I'll also have to import the winner interface here. And now let's look at the logic of this function. So how are we going to detect if there's a winner for the game? Well, if we think about it, let's have a look at the board again. There's actually not that many different possibilities for a player to win the game. It's basically all the 3 horizontal lines, the 3 vertical lines, and the 2 long diagonals. So in total it's 3 plus 3 plus 2 equals 8 different winning lines that are possible. And 8 is a low enough number that we can store all these possible winning lines in one data structure. So first, let's create a variable called possible winning line indices. And this is going to be an array of all of our 8 possible winning lines. And each line contains 3 cell indices. So in the first case, it's going to be the indices 0, 1, and 2. So that would be the topmost horizontal line in our board. The next one would be 3, 4, 5. And the bottom one would be 6, 7, 8. So let's also put those into our data structure. So now we have the 3 horizontal lines. Now what about the 3 vertical lines? So those are going to be 0, 3, and 6. Then this middle one would be index 1, 4, and 7. And those are going to be 2, 5, and 8. So let's also put those 3 arrays in here. 0, 3, 6, 1, 4, 7, and 2, 5, 8. And then we have the 2 diagonals, and those are going to be the indices 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0, 4, and 8. And for the other direction, it's 2, 4, and 6. So let's put those 2 diagonals in, and those are all possible winning lines for this game. So if you want to win this game, you have to hit any of these 8 possible lines. And now we want to check if any of the 2 players has his pieces on all cells of one of those possible winning lines. So for all of these possible winning lines that we just found, if there's one of them where one player has his pieces on all of the 3 cells of that line. On all cells described by those indices. In that case, this player would have won the game. So what we're going to do is we're going to find the winning line inside our possible winning line indices array. So we're going to use the find function. So for all of our possible lines, this function that we pass in will be called. And then we can check this line, whether on all 3 cells of this line we have pieces from the same player. So first of all, we need to check if one of the two players has occupied the cells. We cannot just check whether the cells have all the same value because they could all be null, and in the beginning of the game they will all be null. So first we will check if on our board at the first cell index of this line, and we could check the second or third index as well, it doesn't matter, we have to make sure it's non-null, the value that's inside of the cell. So now we know that the first cell of the line is occupied by either of the two players. And now we can check if the player occupying the first cell is the same player that's on the second cell, so index 1. And likewise, we're going to check if the player on the second cell is the same as on the third one, so index 2. So again, to recap, all of these three conditions have to be true. There has to be any player, so anything other than null, on all the cells. And then we have to check if all three cells have the same player on them. So if cell 0 is the same as cell 1 and if cell 0 is the same as cell 2. And this is our condition. So if we find a line that satisfies all those three conditions, then it is a winning line. And then our find function will return this line. And if our condition is not met, then the find function will return undefined. So in the next step, we'll have to check if the winning line is defined. And if it's undefined, so if there's no winning line meeting our conditions, we can also just return undefined from our detectWinner function. And in the other case, so if there is a winning line, we have to return a winner object. And just to recap, a winner object contains the player who has won and also the winning line he has won with, so that later on we're able to highlight this line on the board UI. So we're going to put in here our winning line. Again, we can just use the property shorthand syntax. And also we have to say which player won the game. And to do that, we can just use our winning line and look up the cell value of any of its cells. So we're just going to use the index 0. We could have used the index 1 or 2 as well. It doesn't matter because with our condition up here, we've made sure that they're all the same anyway. So we just have a little error down here, and that's because this value here could theoretically be null. But up here, we've already made sure that it's not null, and the TypeScript compiler is just too stupid to understand that. So it's okay to use the non-null assertion operator, the exclamation mark in this case, because we know that if we have a winning line, then definitely its entries are not null. Okay, so that's pretty much all that we need for our win detection logic, and we're good to go and use it for our game. So back in our board component, before we change anything on our state, we need to run this logic to check if there is already a winner. In which case, no further moves should be allowed to happen because the game is over at that point. So first of all, we will put a check if in our game state there is already a winner, in which case game is already over, so we can just return and do nothing. And then, of course, the more interesting part of it is down here before we change our state. But after we've already updated our copy of the board, we want to run our win detection. So const winner equals detect winner, and then we just pass in our copy of the board. And then when we update the state down here, we also want to pass in our winner here that we just detected. And remember, this could also be undefined if there's no winner yet. And if there is a winner, then the next time a cell is clicked, this will just return and do nothing anymore. So then the game is over. So let's test this out. Let's reload our board. X begins, I put some pieces on the board. And I play this intentionally dumb so that now already X has won the game. But our game info doesn't show that yet, but we'll come to that in a minute. More importantly, I'm not able to continue playing and put any more pieces on the board, and that's exactly what we wanted. Now obviously we want to make this visible to the user somehow. First of all, as I said a few times already, we want to highlight the cells of the winning line, but also we want to change this text down here so that it doesn't say which player's turn it is if the game is already over. Instead, it should say that player X has won the game in this case. So to do that, let's return to our render game info function again. And we want to extend this a little bit. So first we will pull our winner object from the state as well. And then we want this line to only be rendered if there is not a winner yet. And in the other case, if there is a winner, then we render a different span and give it a class name of game_info_winner. And it should just say in here player, and then let's use the player from the winner object. And we also use the uppercase again, player X or player O1. So let's try this. And you can already see player X1, but let's play a new game from the start. Now it says it's X's turn. I put an X, an O, another X, another O. And at some point I will fill a line of O's, and then it says player O1, and I cannot play any further. So basically our game logic is finished now. Now let's take a look at how to highlight the winning line. So for that, first of all, we want to create a new prop for our cells, which is just going to be a boolean isWinner. That basically says whether this cell is part of a winning line or not. And then in our cell component here, we're going to use this prop, and we want to use it to attach a new class name to this, if it is a winner cell. So we want to make this class name string here dynamic. So let me first change this to a template string. And then inside of here, we're just going to ask, is this a winner cell? And if so, we're going to give it the class name boardCell ---- winner. And if not, it's just going to be an empty string. And again, let me make the formatting a little nicer here, like this. Okay, and then we just need to use this class name to restyle our cell a little bit. So first of all, let's copy over the cell styles from our board.scss and put it into our cell.scss. Of course, we have to use the full class name here then. Then down here inside this class, we're going to use the ---- winner modifier. And then we're just going to give it this darker background color. And lastly, of course, we need to pass the isWinner prop to the cells. So to do that in our render cell function in the board component, we need to get that information from the state first of all. So we have to get the winner from the game state. And then we can pass here isWinner equals, and then first of all, is there a winner? And then is our cell part of the winning line of the winner object? So is the index of our cell index inside the winning line greater than -1? So in other words, is our cell index in the winning line? Is our cell part of the winning line? If so, then our cell is a winner and we pass in true, otherwise false. Now let's try this, and there we see the styling is broken. And that's because we forgot to import our SCSS file in the cell component. Let's fix that. And now this looks much better. Let's put some pieces on the board. And then at some point X has won the game, and you can see the winning line gets highlighted. Perfect. But if I then want to start a new game, I would have to refresh the whole page, so our application gets reloaded. But this is not very nice. It would be much nicer to have a button that I can use to restart the game whenever I want. And to do that, we're going to go down here underneath our render game info call. We're going to call a new function called render restart button. And then we're going to create that function up here. And in there, we're going to create a div first of all with class name restart. And inside of it, there's going to be a button, restart button, and it's just going to say restart game on there. And then let's create a little handler function for when this button is clicked. Let's call it handle restart click. And then we can just call it from our onClick here, handle restart click. And then what does our handle restart function do? That is quite easy, because if you remember, in our game utils, we put an initial game state that just contains basically all we need for a fresh new state of the game. So with an empty board and it's player X's turn. So that is what we can use here. We can just call our setGameState function and pass in our initial game state. And that should be all. Let's check if this works. We click the button and a new board appears. And anytime in between, if I'm unhappy, I can just click the button and it goes back to 0 and I can start a new game. Let's also style this button a little bit so it looks a bit nicer. So basically we're going to create a selector for our restart. First of all, it's going to be centered like everything else. Then there's going to be a bit of margin to the top. And then the button inside of it will get a little padding of maybe 12 and 32 pixels. A little border radius, that's always a nice touch. A border itself, of course, and let's use our bright turquoise again. Background color will be our darker teal color. Text will also be the bright turquoise. Make the font size a little bigger. The font weight will be bold. Cursor pointer is always important for a button. And then to wrap it up, I'm going to put this little box shadow in here with our teal color as the shadow color. And then also, as a nice touch, we want to give this button for its active state, so while it's clicked, a transform property that scales it down to 97%. So while I'm pressing this button, it gets scaled down to 97%. And to make this size change animated, so it doesn't just jump from one size to the other, we're going to use a transition for 0.1 of a second on the transform property. And we're going to use ease in out as the timing function. So this looks a lot nicer. You can see if I press this button, I really press it into the page, so it scales down a little bit. And it's still usable as a restart button. And there it is, our finished tic-tac-toe game with React.js. So now it's your turn. Do you have any ideas on how to improve this game? Leave them in the comments. And don't forget to like and subscribe. I'll see you in the next video.